All right, you've learned to do limits with a table, but remember, with a table, you're just getting an educated guess. You can't be positive that your answer is exactly right. And then you learn to look at a graph, hopefully, and try to tell if there's a limit according to the graph and make an educated guess on what that is. Now, sometimes those educated guesses are exactly right. If those educated guesses are exactly right, you get full credit. But if those educated guesses are not exactly right, you wouldn't get full credit. So what we're going to do is we're going to get some limit rules. Now, I'm going to give you the formal mathematical definition of a limit when we're in class. So I'm jumping a little bit ahead, but I think that on a video is not going to be good. So I'm going to jump a little bit ahead and give you kind of some shortcut rules, some limit rules, so that you can get exactly the right answer. But you're going to have to memorize the rules. If you don't know the rules, you can't play the game. Okay, so just like usual, I'm going to pull up a PowerPoint, I hope, and we're going to go over it. Okay, so these are the limit rules. Now, don't freak out when I show you the initial list. All right, these are kind of your little ones that you learn, and then I'm going to show you some bigger rules that help you avoid these sometimes. Okay, but you have to learn them. Now, here's the deal. Remember what a limit is asking you. A limit is asking you when the x value is getting close, what's happening to the y value? So it would be like, what's the limit of 4? So that would be a number as x approaches a number. So on the graph, now notice what your graph is. Your f of x, your function. Okay, let's see if we can get it to do. All right, so do we understand that in that example right there, f of x is 4? Okay. Now, isn't f of x the same thing as y? Well, think about if you had a graph. All right, if you had a graph and I told you to graph y equals 4, wouldn't you get a horizontal line up here that's 4 units above the x-axis? So do you understand, it really wouldn't matter what number you were getting close to, whether you were approaching 1 or -11 or 100 out here. Everywhere on this graph, the y value is 4. So no matter what your x value is, when the graph is y equals 4, your y value is 4. So that's why the limit of a constant is that constant. So the limit of 4, if you're approaching 10, still going to be 4. The limit of 4 is you're approaching the square root of 10. Doesn't matter. It's 4. So the limit of a number is that number. So the limit of 5, no matter what you're approaching, is 5. So the limit of a constant is that constant. So you need to memorize that. Now, this one is really a special case of this one. All right, but again, notice, this is your f of x. F of x is x. So in other words, y is exactly the same thing as x. So remember, if you were graphing that picture, okay, remember what the graph y equals x looks like. So that's your coordinate axis. Wouldn't y equals x basically split here and here? And think about the points. You would have the point like 1, 1, and 2, 2, and 3, 3. So on this graph, the x and y coordinates on all those points are the same. So if x is getting close to 2, wouldn't y be getting close to 2? If x is getting close to 5, then y would be getting close to 5. Okay? So the limit of x, as x gets close to c, that c just gets put in there. All right? So do you understand? If it said, what's the limit of x as x is approaching 12, the answer would be 12. Now, that's really a special case of this one. I mean, isn't your power right here really a 1? So all I'm doing is plugging 2 in for x. So that's what you do here. If x is approaching 3, then x squared is approaching that 3 goes in for that x, and 3 squared would be 9. Because again, you'd be on that y equals x squared parabola. And on this graph, to get the y part, you square the x part. Okay. Now, all that's happening here is it's saying that if you have a number in front of a function, you've got permission to pull that number out front. So like this, what's the limit of 2x as x approaches 4? Now notice, that's like number 2, but that says the limit of x. It doesn't have a number in front of it. But if you've got a constant in front, you can take that constant and you can pull it in front. So I pull that 2 in front, and then this right here, try to do it again. That thing right there is just rule number 2, which says that that number gets put in for x. So the limit of x as x is approaching 4 is 4, and 2 times 4 is 8. Now, what does this one do? This one says if you have the limit of a sum, you can do the limit of the first one, plus you can do the limit of the second one. It also works with a minus. So look what happens. What if you have the limit of x plus 5? Because it's a plus, you can do the limit of the first one, and then plus do the limit of the second one. And then do you understand that this thing right here is just rule number 2? And this thing right here is just rule number 1. The limit of a constant is that constant. So 2 plus 5 then would give me 7. It would work if it was a minus. I could separate them. So the limit of a sum is the sum of the limits. All right. The same thing works with minus with the difference. Now, it also works with multiplication and with division. You can separate them. So if you've got a limit of a product, you can do the limit of the first one times you can do the limit of the second one. So another way of working this problem down here, some people would see it as a 2 times an x. So you could do the limit of 2 and then times the limit of x. And then this is rule number 1. So the limit of a constant 2 is that constant 2. And this one is rule number 2. The limit of x as x approaches 3 is 3. Okay, so I get 6. So that's you could look at that, or you could pull that 2 out and get the same answer, similar type problem that you got down here. It works with the quotient. You can do the limit of the top divided by the limit of the bottom. So if you had the limit of x over 3, you could do the limit of x on the top and the limit of 3 on the bottom. Then this numerator is rule number 2, and this denominator is rule number 1. Okay, so let's kind of look at a longer one. So make sure that you pause the video and copy all this in your notes and have it next to you before you go to the next slide. Okay, so pause the video and copy all this in your notes, and then proceed to the next slide. All right, so you're back. So what if you had a longer one? All right, do you understand that this one, let me kind of look at this a second, that I've got a 4 times an x squared. So I used one of my rules. So I went back to rule number, let's see if I can figure out which one it is. Where's the multiplication one? See, that's rule number 6. So I'm going to use rule number 6. And I'm going to split it up and do the limit of the first one times the limit of the second one. Now I can already do that one. That's rule number 1. The limit of a constant 4 is that number 4. That's rule 1. Then this is rule number 3. When you've got the limit of x to a power when x is approaching 3, I can just take that 3 and plug it in for that x and get 3 squared. And then remember, you've got to use your order of operations. You do exponents before you multiply. So 3 squared is 9, and 9 times 4 is 36. All right, what if you had this one? All right, do you understand that I'm going to do rule number 7 about a quotient? So that's the limit of the numerator divided by the limit of that denominator. All right, then notice what rule I'm going to go back and use. I've got sums, so I'm going to go back and use rule 5. All right, so rule 5 says that's the limit of the first one plus the limit of the second one. Same thing down here. The rule 5 says it's the limit of 2x plus the limit of 1. All right. Then I'm going to go use my product rule. So you've got your sheet next to you. I hope your notes. So I'm going to do this rule number 6. Okay. So that's the limit of the first one times the limit of the second one. And then plus, I've still got that. And I'm going to use that same rule, the limit of the first one times the limit of the second one. Now, this is just rule 1. The limit of a constant 6 is that constant 6 times, and this one's rule number 2. The limit of x as x approaches 1 is just 1. That's rule 1 again. The limit of a constant is the constant. So that's another rule 1. The limit of 2, no matter what you're approaching, is just 2. Times, that's rule number 2. And then this is going to be rule number 1. And again, you multiply before you add. So 6 times 1 is 6 plus 5 is 11. 2 times 1 is 2 plus 1 is 3. So I get 11 thirds. Okay. So when you've got a longer one, the problems can get really kind of long when you're going and using all these individual rules. Now, I'm going to show you a way to avoid these rules sometimes. Not all the time, but sometimes. So you do need to learn these 7 rules or you're going to get lost later in the semester. Okay. Now, instead of working these a longer way, the way I did here, I'm going to give you another theorem that is a shortcut. All right. I'm going to give you about 3 of them and then show you some problems and then show you another one. All right. Here's what it says. If this thing after the limit is a polynomial. Now, what's a polynomial? A polynomial means that you've got some algebraic terms put together with pluses and minuses. The powers on the exponents are positive or whole numbers. If that's true, then you can just take this number and substitute in for that letter. Okay, so if you've got this long polynomial, you can just, everywhere you see x, you can just plug in a 2. So that x right there got replaced with a 2. That x right there got replaced with a 2. And then I use my order of operations. 2 squared is 4. So 6 times 4 was 24. Okay, and then plus, we got to do multiplication. So I get a 14. All right, so that's going to give me 38. And when I subtract 3, that's where I got that 35. So as long as you've just got a long strung out polynomial, instead of going back and using all these rules here, you can just take that number and plug it in. Isn't that nice? Now, let me show you something else that's true. Here's another shortcut. If you've got a rational function. Now, what's a rational function? It's a polynomial divided by another polynomial. So if you've got a polynomial on top of another polynomial, again, you can take that number and plug in for that variable if that bottom does not go to 0. If that bottom goes to 0, you cannot do it. So let me show you where it would work and where it wouldn't work. When I see a polynomial divided by another polynomial, the first thing I try in my head is to take that number and plug in for that letter. So everywhere I see x, I put a 1. Well, 1 minus 5 is a -4, and 1 minus 2 is a -1, and negative divided by negative, I get a +4. So it worked, so I'm finished. Now, it doesn't have to be a pretty number. It can be like -17/48. All right, but you have to get a number answer. All right, when can you not use this rule? I can't use this rule on this one. If I try to take a 1 and plug it in, I would have 1 plus 3 on top of, and I would have 1 minus 1. Well, look what would happen if I did that. I'd get something on top of what? What's 1 minus 1? 0. And this thing says if the bottom goes to 0, you cannot do that. So I better not see that on your paper if that bottom goes to 0. So what would you do here? Well, we're going to talk about some tricks that you can try. They're not going to work on this one. So if you've got one where the bottom goes to 0, there's some tricks. If the tricks don't work, what you can do is make a table and get a guess off of the table. Okay? So, or you can look at the graph and get a guess off the graph. For most people, the table's easier to see. So on your first test, if you've got one that you cannot do, make a table and give me a guess so you can get some credit. Okay? So when you got a polynomial, you can just take that number and plug it in for that letter and be finished. If you've got a polynomial on top of another, you can just take that number and plug in for that variable as long as you get an answer. But if that bottom goes to 0, you need to erase it and make a table and try to get a guess. Okay? Now, let me show you a couple of other things real quick. It also works with a root. Okay? So that's what this next one's going to say. If you've got a radical, if you've got a root, again, you can take that number and plug in for that letter as long as you get an answer. Now think about what they're saying here. What if you ended up, when you plugged in, what if you had the square root of like a -4? Do you see that that would be terrible because we can't do the square root of a negative? So when this index number is an even number, all right, when this index number is even, you got to be careful because when you plug in, if there's a negative answer under the root, you can't do that. Now, look what it says. When n is odd, you can always do it. Now think about why. What if you had the cube root of a -8? Okay, well, that's -2. Because a -2 times a -2 is a +4, and a +4 times a -2 is a -8. So you can have the cube root of negative numbers, positive numbers, or 0. So if this index number, this n right here, if it's odd, you can always take that number and plug it in and be finished. But if this index number is even, you can only take that number and plug it in when you get an answer. All right? Now, here's some others that you need to memorize. It basically says when you've got trig, or when you've got numbers to letters, or when you've got logs. You can also just take that number and plug it in for that letter as long as you get a real number answer. All right. So let's go look at something. So basically, I want to make sure we're clear about this. What this slide, and this slide back up here basically say is you can take the number and just plug straight in for the variable as long as you get a number answer. But now, so look right here. That's always the first thing I try. Okay. I try to take that 0 and just plug it in and see if I get a number answer. Well, 3 times 0 is 0. 0 minus 2 is a -2, and the -2 to the 4th gets me a number answer of 16. Okay. I take that pi/2 and plug it in for x. So that x comes out. So I take that x out, and in place of that x, I put pi/2. Now, what's 3 times pi/2? Wouldn't that be 3 pi/2? So this is just asking you what's the cosine of 3 pi/2. Remember, that's 270 degrees. So on your unit circle, 270 degrees would be down here. So that'd be the point 0, -1. Remember, cosine is your x coordinate. So your x coordinate right there is 0. So your answer is 0. Okay. Look right here on this limit one where you got a root. Again, I can take that x out and just stick a 2 in there as long as I get an answer. All right. So when I plug a 2 in there, 12 times 2 would be 24 plus 3 would be 27. And the cube root of 27 is 3. Now I want to make sure we're clear. You don't have to get a pretty answer. What if that had been a 12? Well, 12 times 12 would have been 144, and 144 plus 3 would be 147. All right, so my answer then would have been the cube root of 147. Now, that's not a pretty answer, but it's still an answer. So the first thing you do is you try to take that number and plug in for that letter. If it works, you are finished. Now, this one doesn't really fit any of those. So I'm going to have to kind of go back and use kind of one of my rules. I mean, if I go back and look, this one doesn't really fit any of the rules that I've talked about. But remember, that means times. So I went back up here and I'm going to use this rule number 6. I'm going to break it up and do the limit of the first one times the limit of the second one. Okay? So the limit of the first one times the limit of the second one. Now these are some of my other ones that I learned back up here. All right. Remember, A is a number to a letter and E is a number. Okay, so because E is a number, I can just take that number and plug in for that letter. So I just replace that X with a 0. Well, now what's the opposite of 0? Isn't the opposite of 0 still 0? And any number to the 0 power 1. And then remember, I can just take that number and plug it in for that letter. So I plug 0 in for X. Well, 0 times pi is just 0. So what's the sign of 0? Well, you know, the 0 is right here. All right, so we realize that 0 is right here. So on 0 degrees, again, what's your sign is your Y. So your Y value is 0. And then 1 times 0, 0. So basically what I'm kind of showing you right here is this. The first thing you're always going to try on limits is you're going to take that number and you're going to try to plug it in for that letter. If you get a number answer, then you are finished. Now, if you try to plug it in though, all right, and it doesn't work, like down here, if I take 1 and try to plug it in and it doesn't work, you can always make a table and get a guess. Now, here's what I do first. So you might want to write this in your notes, limit. So the first thing I try is I try to just substitute the number in for the variable. If that works, I am finished. If that doesn't work, there are 3 tricks. Your book calls them techniques that you can try that I'm about to show you. If none of those work, then my last option is to make a table and get a guess from the table. So the tables are kind of in case of emergency break glass. You only use those in an emergency when you got nothing else you can do. Okay, so try to take the number and plug it in. If that doesn't work, then I'm going to show you some techniques. So techniques when those rules don't work. All right, here's one thing you can try. You can try to factor it. Sometimes it helps, sometimes it doesn't. I'm going to show you like one time it does and one time it doesn't. This is the difference of perfect squares. A squared minus b squared. You know, a squared minus b squared factors into a minus b times a plus b. We got to be able to factor. So I factored x squared minus 1. Now look what happens when I factor x squared minus 1. Do you see that I've got an x minus 1 up here and I've got an x minus 1 down there? So I'm going to divide those two things out. And that's going to leave me just the x plus 1. All right. So now I can take that 1 and plug it in. And 1 plus 1 is just 2, and I'm finished. So sometimes when you factor, the thing that's causing the trouble will divide out. But now I want to warn you about something. For you to do this on a test, you've got to write me this note. Because here's the deal. What you're really saying is some number divided by itself you're declaring that that is 1. And most of the time that's true. I mean, like 6 divided by 6, that's a 1. if you had a -2 over a -2, that would be 1. If you had the square root of 5 over the square root of 5, that would be 1, okay? But there's one time when a number divided by itself is not 1. 0 over 0 is not 1. That's something we'll talk about later that's called an indeterminate form. So you can't cross out 0 over 0 and declare it to be 1. So how do you know that you didn't do that there? How do you know that's not 0 over 0? Well, think about it. When's the only time that x minus 1 over x minus 1 would be 0 over 0? Wouldn't x have to be exactly 1? If x was exactly 1, 1 minus 1 would be 0. So what in this problem guarantees you that x is not 1? This does. Remember what x approaching 1 means. It means you're getting closer and closer, but you never get there. So x approaching 1 guarantees you that x isn't 1. And as long as x isn't 1, x minus 1 is not 0. So for you to start crossing something out, you've got to write me this note. X approaching 1 guarantees, and you can say that x is not 1. If that makes more sense to you, then x minus 1 is not 0. Okay? So sometimes factoring saves you. Sometimes it doesn't. See, if we look right here, if I tried to take 1 and plug it in, I'd get a -3 on the top, but I'd get 0 on the bottom, and I can't do that. So I think, well, that factors. Yeah, it does. But see, after I factor it, nothing divides out. So factoring did not help me. So what would I do? I'd have to make a table and get a guess. Okay? So when taking the number and plugging it in doesn't work, the first thing you should try is try to factor it and see if it helps. Sometimes you can't even factor it, so it's not an option, but factoring is one thing you can try. Now, here's another thing you can try. If you've got a root in the problem, then you can what's called multiply the top and bottom by the conjugate. Now, this is back in Algebra 2. A conjugate means that the root stays the same, and this next thing stays the same, but the minus turns into a plus or the plus turns into a minus. This right here is the conjugate of this thing. So what happens is the minus would turn into these would be opposites of each other. So if this one's plus, this one's minus. If this one's minus, this one's plus. But now remember, the only thing you can multiply something by and not change it is 1. So if you multiply the top by that ugly thing, you've got to multiply the bottom by that ugly thing, because this is just a weird way of saying 1. And you can multiply anything by 1 and not change it by your identity property of multiplication. So if you've got something with a root, you can try to multiply by the conjugate. See, factoring won't help me here. I don't know how to factor that. Now, here's the trick. Only multiply out where that should say root, okay, originally was. Now, what do I mean by that? All right, go back and look at the original problem. All right, here's your original problem. Was the root on the top or the bottom? See, the root originally was on the top, so I'm only going to multiply out the top. So here's what I did. I said the square root of x plus 1 times this, I'm foiling it. It's what y'all call it. I don't like that term, but this one times this one, square root of x plus 1 times the square root of x plus 1 makes the root go away and gives me x plus 1. So I've done this one times that. Now I got to do this one times that. So the square root of x plus 1 times 1 is the square root of x plus 1. So now I've done this one times both of these, so I got to do this minus 1 times both of those. So a minus 1 times that root gives me minus that root. And then a -1 times a +1 gives me a -1. So you multiply it out where the root was originally. Now, do not multiply out the bottom, just write it out. This denominator, and then put a parenthesis times that denominator. But don't say this one times that one plus that one times that one. So if the root had been on the bottom originally, I'd have multiplied out the bottom. So only multiply out where the root originally was. Now, clean it up. Do you see that I've got plus this root and minus this root? So that and that go out. So that leaves me x plus 1 minus 1. And I just copied that denominator down. Now 1 minus 1 goes out, so I've got an x on the top and an x on the bottom. Now notice what happens. Can I divide this x and that x? But again, how do you know it's not 0 over 0? What in this problem guarantees you that x is not 0? That does. So you've got to write me that note. X approaching 0 guarantees that x is not 0. So now everything's gone from the top. So I've got a 1 on the top, and then this is left on the bottom. Now it still looks nasty, but if you take 0 and plug it in for x, you get an answer. 0 plus 1 is 1. The square root of 1 is 1. And 1 plus 1 is 2. So I get a half. So one option is to try factoring. Sometimes it works, sometimes it doesn't. See, factoring wouldn't help me on this one. If you've got a root, then you can multiply the top and bottom by the conjugate of that root expression, which is the same thing, but changing minus to plus, or if that was plus, you'd have a minus. And the reason you use the conjugate is so that that root will go out. Now, what if neither of those work? Well, there's a third option that works sometimes. This is called a complex fraction. Now, complex doesn't mean complicated. A complex fraction means part of your fraction is a fraction. So what you can do is you can try to play arithmetic and try to simplify it. So what do I mean by that? Here's what I mean. I'm going to just go work with this top part over here to the side. This is why that was on your review sheet, on your algebra trig review sheet. I'm going to try to rewrite these two fractions like one fraction. So I'm going to take this one minus that one. I'm going to do this little subtraction over here. So I need a common denominator. So your common denominator is going to be 4 times x plus 4. So we talked about this in class, remember? What is this denominator? How did this denominator right here turn into this new denominator? What would you have to multiply x plus 4 by to get this? Wouldn't you have to multiply this by 4? Well, if you multiply the bottom by 4, you've got to multiply that top thing by 4. So I took my old numerator and multiplied by 4, and then minus. Now look at this old denominator. This was a 4 and it turned into 4 times x plus 1. So how did you turn that denominator into that one? Wouldn't you have to take that and multiply by x plus 4? Well, then you've got to take this old numerator and multiply by x plus 4. So I multiplied it out and got 4 minus, well, 1 times x is x, and then minus 1 times 4 is 4. And see, those 4s go out. And so that leaves me a negative x over that. So do you understand that what I'm about to do is this? I'm about to replace these two things with this one thing. So I go over here and I'm taking these two things out and I'm replacing it with the answer with that one thing. Okay? Now it still looks complicated, so let's see what I can do now. Do you see that I've got this black fraction divided by x? So I wrote it the way that you would write division problems in 3rd grade, like 1/2 divided by 2/3. Well, now how do you divide fractions? Don't single things go over 1. All right, most of you keep the first one the same, and then you change that to times, and then you flip that one. You multiply by the reciprocal. Now, why does that help? Because see, those x's go out. So now I'm left with a -1 over this thing. So notice what you did. You've exchanged this horrible fraction up here for this one fraction down here. So you've simplified this complex fraction. Now, when you take 0 and plug it in, you get an answer. 0 plus 4 is 4, and 4 times 4 is 16. See, I couldn't just take the 0 and plug it in up here because then the bottom of my fraction would have been 0. All right. So what we've learned is this. The first thing you always try is you try to just take the number and plug it in for the letter. If that works, you're finished. If that does not work, then you've got 3 tricks. You can try factoring and see if that helps. If it helps, again, you're finished. If it doesn't help, see if you've got a root that you can multiply by the conjugate. See if that helps. If it helps, you're finished. If that doesn't work, if you've got a complicated fraction, a complex fraction, try to turn this complex fraction into one simpler fraction and see if that helps. If none of that works, your last option is to make a table and get a guess off the table. Okay? So that's what you're going to do with limit rules. Try to plug the number in first. If that works, yay. If it doesn't, see if factoring helps, or multiplying by a conjugate if you've got a root, or if you've got a complex fraction, try to simplify it. And if none of that works, you're going to have to make a table and get a guess off the table. Okay? So you try that and then go to Thursday's homework, and then I will see you in class on Tuesday.